Welcome to your very first lesson in our flipped classroom for AP Precalculus. You should have your packet with you. I'm going to work through this and you follow along. So make sure that you are taking notes as I do, and make sure you watch to the end of the video because there will be a question that you will be required to answer. So let's dive right in. We're diving into Unit 1, Lesson 1, Change in Tandem, and you can see what our skills are right here. So, to get us started here, we're going to just do some basic definitions. A function is a mathematical relation that maps a set of input values and output values so that every input value is mapped to exactly one output value. That should be something you're familiar with. Keep in mind, you've probably used what's called the vertical line test in the past to figure out whether something was a function or not. Vertical line test is a great strategy to use. However, later in this course, we are going to talk about some polar functions, and when we graph a polar function, that is actually not going to fit in with that rule. But as a quick reminder, vertical line test means that if a function is a function, then you should never be able to draw a vertical line that crosses it more than once. So if you had a graph like this, that would not be a function because we would cross more than once. Every input needs exactly one output. Now, another set of vocabulary words here. Input values are the domain. Those domains represent the independent variable, which is our x variable. The output values are called the range. Those go vertically on a graph. They are the dependent variables. They are impacted by the input. So that gives us our output or y variable. A function is considered positive when f lies above the x-axis, f being the function. So even though we have y here, you're going to mostly call these like f of x, g of x. So if f of x is the name of the function, f lies above the x-axis, that means that the outputs or y values are positive. So a graph would be positive here, even if it's decreasing. But it would become negative once it dips below this x-axis. So positive above right here, negative below right here, but the slope the whole time is decreasing. So that's a key thing that we want to focus on here. A function can be positive, but that does not mean that it's necessarily increasing. Now, we've got some vocabulary all set up. Now we're going to look at multiple representations. Throughout this course, you're going to need to know graphs, equations, tables, and verbal explanations. All of these will be on the AP test. So let's actually dive into it. This is a fun problem. I'd love for you to try this one on your own. To do that, we have a vase here. See this vase? It's getting wider, then narrower at the top. Imagine at time 0, you start pouring water into this vase. When you pour that water in, you're pouring it at a constant rate. That's a key word. That means that the amount of water you're pouring in is not changing. Which of the following would depict the situation where time is measured in seconds and the height of the water is in inches? Which of these do you think would be the best the best graph of that? I apologize, I was off screen. I need to work on that. But pause your video, figure out which of these do you think would compare the height of the water vertically as compared to the time it takes to fill. All right, my hope is that you were able to think through this. Hopefully, you better have actually paused. Let's go ahead and take a look. A, would this water depth get this equal slope the whole way, the same change the whole time? Why or why not? Well, if you look at it, it's getting wider. So even if you're pouring in the same amount of water, it's got more width to fill. So as you fill that vase, it would change the rate at which it's filling. So A is obviously wrong. Now the height of the water is never going to just suddenly start decreasing unless you break that vase. So definitely not going to be C because we're going to assume this thing doesn't break. So now our question is B or D. Well, is it going to speed up or slow down as you fill? Well, it's getting wider initially, so it's going to slow down. It takes more water. Since it's slowing down, the slope, the change, right, is going to decrease. So it's going to become less steep. So looking at these, it's going to become less steep as you fill it. And then, as it gets narrower, it'll require less water to fill. You ever notice when you fill a water bottle at the top, it starts to go really fast? Well, that means it would accelerate. So we'd start going back up. So the answer here would be D. Next up, we have graphical behavior of functions. Increasing is just when the line is going up, right? We have a positive slope. So it says if A is less than B, then the function A is less than the function at B. So that means if the input is getting larger, then the output is getting larger. That's what this terminology means. Decreasing is just the opposite. It's a negative slope more. Now, jumping here, concavity is another term. Yeah, concavity, if you think of caves, they have an opening, right? So is this opening going up or down? Well, the opening is pointing upward. So that means that the slope is always increasing. That may sound weird. Concave up means that the rate of change or slope is increasing. You may be questioning that. So let's look at an example. For example, over here, this function's decreasing here, right? It's got a negative rate of change. Here, this now becomes a slope of 0. So negative slope becomes 0 slope becomes a positive slope. And here's the thing, it's less negative, less negative, less negative, less negative, 0. Positive, more positive, more positive, more positive. So when you have a concave up function, the rate of change is increasing. Same with concave down. Here we have a super positive slope, it's really steep. Here it's getting a little less steep, so it's getting less positive. Then you hit 0, there is no slope. Then you curve and start going down. Remember, we're going left to right, so this is going to start going down at faster and faster rates, so it becomes more negative. So the slope is becoming more negative the whole time. Even though this is going up, the slope is decreasing. I hope that's clear. Before we go on, I want to clarify just some notation and vocabulary that we're going to use in this class. First, when we're describing features of a graph, we write intervals where those features are happening. Intervals are ranges, I shouldn't use the word range, domains of x values, where you're talking about the input always. So let's take a look at what that would be. On the next page, we have this function here, a graph of f. It is a piecewise function because it's made up of 3 linear equations, and it shows it over the interval 0 is less than or equal to x, less than or equal to 9. What are the intervals where the graph is increasing? So we're increasing. So even though this is less than 0, it's going up. The slope is positive. So from -2, less than, and it does have a closed circle, so the function can be equal there. So I put a less than or equal. We're talking about the domains or x values, and it stops at 3. So that's pretty simple. Another way we will write that is like this, where I use a bracket to imply equal to. If it was not equal, if it was just less than, I would use a parentheses. We want to make sure we're familiar with either of these two notations because they mean the same exact thing. Go ahead and write down the other interval where this function is increasing. Did you write it down yet? Did you? Did you get it? Did you get it? All right, well, it should be 7 less than or equal to x is less than or equal to 9, which could also be written as 7, 9. So that's called interval notation. We want to make sure you know both. Y'all, I'm upside down. This is where it gets real, okay? So this is where people start to get confused. Pay close attention. We're going to talk about rate of change, which you should know is slope. Slope is the change in y values divided by the change in x values. Remember that a positive slope means that we are increasing going up, and a negative slope means that you're decreasing going down. But that is going to get a little more complicated here. Let's take a look at these two examples. First off, we need to separate the difference between the function and the slope. Because, and if you look at this function is a graph. That graph is entirely above the x-axis. So that means all of the numbers for all of the outputs are all positive. So in this case, graph f, function f is positive because it's above the x-axis the whole time. Looking at this one, this is function g. G is, well, it's below the x-axis. So g is negative. Now let's look at what their slopes are doing. Well, this is going down. It has a negative slope. If it has a negative slope, that means that f is decreasing. And this one, the slope is going up. So g is increasing. It's going up. But here's where it gets tricky. This is going down, but it's going down slower and slower. Since it's becoming less negative, the rate of change is actually doing what? It's becoming less negative. So the rate of change is increasing because this is concave up, it's curving up, it's becoming less negative. So these are three different ways to describe this function. The function is positive and is decreasing, but the rate of change is increasing because it's less negative. Over here, let's take a look. This g function is negative because we're below the x-axis. However, the function is going up. This rate at which it's going up is slowing down. It's getting less steep. And so since it's getting less steep, less positive, the rate of change is decreasing. So what does this bring us to? It brings us to this question here. Which of these functions is negative? This function. But which function is decreasing? This function. Which of these rates of change are decreasing? This one. It has a positive slope, but it is a decreasing slope because the slope is getting less positive. This one has a negative slope. It's going down, but it's increasing. It's becoming less negative, and that often confuses students. So let's try a couple of quick examples. And here's the cool thing. This is day one of the class, and you can already see an AP style question. So take a look here. The graph of h of t and its dashed midline for 2 full cycles is shown. 5 points are labeled on the graph. No scale is indicated and no axes are represented. The t-coordinate of f is t1. The t-coordinate of g is t2. So I'm going to label that. F is time 1, and then g is time 2. So on the interval from t1 to t2, f to g, which of the following is true about h? Well, we're above the midline. The output values here are positive, 0, then they go to negative. So the output values are currently from t1 to t2 positive. The slope is a negative slope. Is it getting more negative or less negative? It's becoming more negative. So on the interval from t1 to t2, which of these would be true? Well, technically h is positive, so I can get rid of this and this. Now, is this function increasing or decreasing? Oh, it's going down, so it's decreasing. They didn't actually ask me anything about the slope on this one. Oh, here it is. It comes in at part B. Describe how the rate of change of h is changing on this interval. Now this is where that language really starts to matter. We want to say the rate of change is decreasing. It's becoming more negative. Now that wouldn't be true for all of the intervals. So make sure on these next examples, which you're going to do on your own, that you are carefully checking the interval given. I did want to add one more thing. We said the rate of change is decreasing. Is this curving up or down? It's curving down. So that means it is concave down. And when something is concave down, that is a decreasing slope because it is concave down. We want to make sure that we give a description of what's happening and why it's happening. So go ahead and include that on the next example.
All right, y'all, you should have looked at this, checked the output values on K and P. They go from -4 here to -1. So they're negative. The outputs are negative. This is below the axis, so this function is negative. Now, -4 to -1 means that this function is increasing, right? It's going up. So C was your answer. Now, the next part of this said to describe how the rate of change is changing. That's weird. How is the change changing? Well, it is getting less steep, right? It's going up, and then it's getting closer to 0 before it goes back to negative. In that case, the slope is decreasing. So you would say the rate of change is decreasing, and your justification would be because it is concave down, right? Trending downward. Now, for number 5, which I asked you to do, your answer also should have been C. I need you to now do examples 6 through 12 to finish up this lesson. Once you finish those, write down any questions you have, bring them tomorrow, and we'll go over this in class. Awesome job. Thanks for staying focused and locked in. We'll answer any questions you got in class.